going down. I'm yelling timber.
In this lab, we got 24-volt power supply coming over to the amplifier. The amplifier is giving off a 5-volt DC reference for the potentiometer. And we're using the potentiometer to vary the control signal that's going to the proportional flow control valve. As you can see, come over here and get a video on this. As you can see, as the command voltage increases, the speed of the motor also increases. It's proportionally controlling the speed. Okay, in this lab, we are using the PLC as the command signal that's coming in and being amplified to the proportional flow control valve to control the flow of the motor or the speed of the motor instead of using a potentiometer. The program for the PLC is going to have 2-second deadband and then 5-second ramp up or acceleration, 10 seconds of steady state speed or constant speed, and then 5 seconds of the deceleration or ramp down. And as you see, if you watch the voltage meter along with the motor that the input signal proportionally controls the motor.
This was, lab 10 was taking a look at wiring to make sure everything was correct, and then lab 11 was monitoring and adjusting proportional, directional, and flow control systems.
Here's your directional and flow control valve with the LVDT for a positioning sensor.
Okay, we can see over here where if we're adjusting this potentiometer, this is the command voltage, this is the full positioning voltage reading, and as you can see, if this is turned up or down, you can see that the voltage is changed, and then you can see that the motor is spinning more or less. And then at a certain point, when this goes into negative, it's actually reversing the direction of the motor spinning. You can see that that's actually slowing down. It's actually reversing. It'll eventually reverse. See it slowing down?
Slowing down.
It's actually reversing to another direction. And you can see here, it's now in negative. It's going slow, and then when it goes way up in negative to like it's going into 9 and 10. Well, it's going to go to maximum speed.
May 2014, we're finishing up the final lab of IA-243, I think SC4. The final lab is to do a safety circuit. It's called an anti-tie down. We have a stop button, of course. Which will de-energize the whole system, as shown on PL2 here. If we press both, it's within about a second or 2 seconds of each other, the system will activate, as shown on PL1, which is here. Okay, that prevents any operator from having one hand on, not the other. Now, say an operator wants to tape down one of these to defeat it and wants to press the other. We have a timeout circuit here, so it de-energizes after about a second or two. And that's shown here on that light. Now, with that in mind, I've hooked up that light, but what's supplying that light with air was supposed to bleed off. I'm going to go over here and take that off. Well, let me leave it on first, and I'll show you why. Because that leaves air in the system, which will be dangerous, the way it's set up. See how that still goes? Properly done, this wouldn't be here. I'm just doing that for display purposes. So to be safe, that air would have to bleed off of off RV. That's RV2. RV1, I'm sorry. So I heard it bleed off there. So now it won't operate. 1002, there we go.
Hit them both.
So there's no way to keep one taped down and then be able to press one button.
And you can't bypass the second safe.
Right. You can't. There's no way to bypass. So that's a safe circuit. Thank you.
You better dance. Let's make it mine. You won't remember. I'll be the one. You won't forget. It's going down. I'm yelling timber.
You on?
Yes.
Two Adams walking down the street. One Adam says to the other Adam, "Hey, I think I lost an electron." Second guy says, "Are you sure?" He says, "I'm positive."